हेलो फ्रेंड्स एंड स्टूडेंट्स, आज हम इस वीडियो में हाफ सबट्रैक्टर के बारे में सीखेंगे। तो आप इस वीडियो को लाइक ज़रूर करना। नाउ लेट अस स्टार्ट हाफ सबट्रैक्टर। In half subtractor, we subtract one digit from the other. So, we will have two inputs. Thus, 2 is for binary and two inputs are there. So, we will have 4 different cases. Let us take our first case, subtraction of 0 from 0. So, the difference 0 minus 0 will give 0. Since we do not have to borrow anything, there is no borrow. So, for the borrow we will have also 0. Now, let us go for the second case. For the second case, we subtract 1 from 0. Since we cannot subtract 1 from 0, we have to take one borrow in this manner. Now, what does it mean? We will have, say, 2 raised to 1, it is equal to 2. So, 2 minus 1, it is equal to 1 over here. Second thing, since there is one borrow, so we will have one borrow over here. So, in this case, difference is 1 and the borrow is also 1. Let us take the third case, subtraction of 0 from 1. In this case, we can subtract, say, easily like this. The result is 1. Since we are not taking any borrow, for the borrow we will have 0. Now let us go for the next case. In this case, subtraction of 1 from 1. Naturally, we will get the result as 0. Here also we are not taking any borrow, so the result for the borrow is 0. Now, let us move further. We can construct our half subtractor using XOR gate, NOT gate and AND gate. We will see whether we are getting the same result as we have seen just now for all the 4 different cases or not. Since we have one XOR gate. So, for the XOR gate, the truth table is just like this. We know that for the XOR gate, if both the inputs are same, that means 0 and 0, or say 1 and 1, the result for the output is 0 and 0. If we have different inputs, say 0 and 1 or 1 and 0, the output it is equal to 1. Thus, for the XOR gate, we will have, say, 1 as the output for different inputs and 0 as the output for the same input. Next, we will have AND gate. For the AND gate, we will have 1 only when both the inputs are 1. Otherwise, the result is 0. For the NOT gate, we have input 0, the result is 1, and input 1, the result is 0. Now, let us go for one by one cases. For the first case, say A equal to 0. And B, it is also 0. So, according to property of the XOR gate, the difference is 0. Now, this input A, it will come over here. After the NOT gate, it is converted to 1. Input B, it is 0. So, according to property of the AND gate, if one of the input is 0, output is 0. So, for difference and borrow, both, say for the difference, the result is 0. For the borrow, the result is also 0. Now, let us go for the second case. For the second case, we will have, say, input A is 0, while the input B, it is equal to 1. So the output of the XOR gate, since there are different inputs, it will give 1 for the difference. Here A is 0, so 0 will come over here. Since here we have NOT gate, it will give 1. Input B, it is equal to 1. So now for the AND gate, both the inputs are 1. So the output for the borrow, it is equal to 1. So the difference is 1 and the borrow is also 1. Now let us go for the next case. For the next case, we will have, say, input A equal to 1 and input B equal to 0. So, the difference from the XOR gate, it is equal to 1. Input A, it is 1 over here, which is converted to 0 due to the NOT gate. And input B is also 0. So the borrow from the AND gate will give 0. So now we will have the difference equal to 1 and the borrow is 0. Now we will go for the fourth case. Last one. For this case, we will have both the inputs are 1. So A is 1 and B is also 1. So the difference from the XOR gate is 0 since both the inputs are same. A is 1, so from the NOT gate we will get 0. And B is 1, so B in the AND gate as an input it will give 1. Again, the AND gate result for the borrow is 0. So for this case, we will get 0 and 0 for difference and borrow both. Thus, if we input 0, 0, the result is 0, 0. Next, 0, 1, the result is 1, 1. 1, 0, the result is 0, 1. And 1, 1, the result, it is simply 0, 0. So now, we can make the truth table for this circuit, half subtractor. Truth table of the half subtractor is given below. Here we have input A, input B, output borrow and output difference. Let us take the first case, both 0, 0. So the difference is 0 and borrow is also 0. The second case, 0 minus 1. The difference is 1 and the borrow is 1. The third case, 1 minus 0. The difference is 1 and the borrow is 0. And the last case, 1 minus 1. It will give difference as 0 and borrow as 0. We can make a K-map for borrow and difference from this table. Let us go for the first one. First one is the difference. We can concentrate on 1 for the difference. So, here for the difference we will have 1 over here. For this one, the respective positions are 1 and 2. Thus, in our K-map, we can use these positions 1 and 2 for the 1. Let us draw the K-map. This is just the formation of the K-map. We can simply write over here input A and input B. From this K-map, we can construct an equation. Here, we will have 1 and 1 for the positions 1 and 2. So, we can write for the position 1 as 1. And also for the 2 as 1. Here we cannot make any horizontal or vertical groups. Here if we concentrate on 1, then this 1 will give the equation as difference. Say for this one we will have A bar B. So we can write A bar B plus for this one we can write A B bar. So we will have A B bar in this manner. So, the equation for the difference can be written as A bar B plus A B bar. So, our equation for the XOR gate is just like this. Now, we will move for the second one. The second is for the borrow. For the borrow, we will have 1 over here. This one stands for the position 1. So, we can simply get our K-map for the borrow in this manner. For borrow, again we can write input A and input B. For this, for the position 1, we will have 1. So, our equation, it will become for this one as A bar B. So, for the borrow, we will have the equation A bar B. Now, let us construct half subtractor using XOR and NAND gates. Say, here we will have the circuit like this. One XOR gate over here. So, we can take the XOR gate as it is. One NOT gate it is over here and one NAND gate, AND gate, sorry. So, we can construct NOT by sorting NAND gates, and with the help of two NAND gates, we can construct the AND gate. So, we will have one XOR gate over here, one NAND gate over here. By sorting the both input terminals, so this will behave as a NOT gate, and this NAND gate output is supplied to the input of the second NAND gate. Here, for the second NAND gate, both the inputs are sorted. So, this will act as a NOT gate. So, NAND gate plus NOT gate, it will give the AND gate. So, we will have one XOR gate over here, one NOT gate over here, and the combination of these two is just the AND gate. So, the circuit is just like this, which can be constructed by using XOR and NAND gates in this manner. So, we have completed, say, half subtractor. Thank you.